tolerance should be much. Like you look like you can't. It is. Next. हमारे देश तो अच्छी बात है चाइना चीन चाइना shooting and wow. I didn't see him on the videos. I just know that we got it. Not dependent on technology. पूरा नहीं करना पड़ेगा impossible que no fue. Hay supuesto. Like the Mahal Sapphire, we have been considered. हमें आप लोग चाहिए होती है Wow. China number of this and then why after that what was the why is that case? Wow. You were the time and space that day. School to go to okay. Wow. अरे क्या कर रहा है? Once again, acting. So
Okay, let's get back to zero. No, no. Next week also we have 2 lectures. Continuous or it is the arrangement for this week? What do you see the timetable?
Yes, sir. Not for that.
Timetable comes weekly.
No must.
Okay, you can check that.
Yes, sir. Can I check right now?
घर पे check करिए. Okay, gravitational potential energy here. What is the formula for gravitational potential energy? mgh, right? So we learned kinetic energy formula. Kinetic energy half mv square and potential energy is mgh. Okay, so very specifically this is gravitational potential energy and this is kinetic energy. So any body whose mass is known and the speed with which it is traveling, you can calculate its kinetic energy by this formula. And any body whose mass is known and also the height from the ground. That's all right.
Yes, sir.
So attention, pay attention here. What is h? H is the
acceleration.
h.
H is height.
H is vertical height.
Vertical.
Where h is vertical height or vertical displacement. Vertical displacement. Because if you say height, it is vertical, right? Now look here. Suppose I have like a lift, okay? I have lifted the body directly to a height h. Like in case of a lift. But you can reach the same height by steps, correct?
Yes.
So the amount of potential energy gained by the body only depends on the actual vertical displacement, not how that height is achieved. Path is not important. Okay, so you could have taken the body like this and then this, then this. Any which way you take the body, okay, as long as the height from the earth is same, it is all going to have same potential energy. Is that clear? So potential energy is independent of the path. Of the path taken. It only depends on the vertical displacement. Displacement from ground. Whenever we say ground, it is earth. Earth's surface. Okay, is that clear?
But it can probably not consider this in form.
This what?
This can come an example with the photo and this, yeah,
Yeah, diagrammatical questions, yes. They may tell you like, okay, they may confuse you. They might give you the depth and like the depth and the weight of the step. And you may total everything and write, then it will be wrong. You have to only take the vertical displacement. Okay, MGH. Because in all situations, H is same. Okay, next is law of conservation of energy. Law of energy. Right. So first you write till here, and then I'll explain what is law of conservation of energy. This you might have already studied law of conservation of energy. Have you? Energy cannot be created nor it can be destroyed. It can only be converted from one form to other form. In chemistry, you have learned, right? For mass,
for mass, like.
mass cannot be created. Like that, there is law of conservation.
Atom.
Oh,
Mass, you know, atom. What do you mean by atom? What is atom?
That is mass. Mass can, in a chemical reaction, mass cannot be created.
Yes. So right now we are teaching you this. But in higher standard, we will tell you that mass also is not a conserved quantity. It changes. Okay. So which is absolutely fair. Right now, we are making you think in the directions that there are certain quantities which are conserved in a physical phenomena, like chemical reaction. But later on, it may not be conserved in a nuclear reaction. Okay. All right. So law of conservation of energy. Right now,
Can energy be conserved?
it is conserved. That's why we are going to study this law.
Yes, yes.
Energy is one thing which is always going to be done. So you're saying as if no change is going to come within you all. I was once like you. Now what are the changes in me? Same changes will also go. Understand? So, but energy, whatever energy, so whatever we are, from where that energy came within us, from the cosmos. So we are just one manifestation of energy. Okay? We are consuming, so energy is increasing, right? And once when we are gone, so is the energy finished? In this form, yes, but it is changed into some other form, gone back to cosmos. It's like that. So energy is one thing, call it soul or whatever, right? So energy does not die, just the body. Okay, so law of conservation of energy. Right now, it states that, right now, fast. Everybody, write the statement, law of conservation of energy. It states that energy can't be created energy can't be created nor be destroyed nor be destroyed. It can only be converted from one form to the other form can only be converted from one form to the other form. Okay? During any physical process.
So how did energy first came
Okay,
into
so
this
questions are same question.
You are asking the question about origin of the universe.
Yes.
So that quest is going on. Nobody exactly knows this.
But you said during any physical
Process.
process, so can it be the change?
Process could be as simple as this. What energy it has and what energy it will have when it hits the ground. Kinetic. So from top to bottom, energy has changed from potential to kinetic.
So I was asking if it is a physical process, if a chemical process, can it is
Any chemical is also a physical process.
what if the picture can be captured?
No, they differentiate. Or you can say any process, during any process. So in physics, we can say physical process. Right? So the definition could. So last line is total energy remains constant. Matlab, if the energy cannot be destroyed, it cannot be created, means you can't add more energy and you can't destroy that energy. So whatever energy a body had, when that body is undergoing some physical process, right? What should you write? Or do you want to remove physical because you have instilled a doubt now? For us, the physical process is, let us say, body under free fall. We are going to verify that. Okay? So it's up to you. If you want, you can write because here they are saying the total energy remains constant at that line also.
But can we really call it a law if we don't know how energy first came into the universe?
Can
Because we have by calculation verified that it actually happens, which we will do right now. And you'll agree with me. Okay.
so that means that the first energy in the universe came from something else. Because
So
energy cannot
assume total energy of the universe is 100%. Can you do this? The whole universe conceivable, which is coming to your mind, let us say, whatever you can imagine, that is universe or multiverse, whatever you can think. I leave it to your imagination. Let's say the total energy is 100%. So what this law says is that energy will remain 100% only. It won't change. But it will exist in the universe in different forms. The 7 forms which I told you.
so that it can be understood that there was that body universe, it's so that there will
So 1, 2, 3, 4, 5, 6, 7. So energy is existing in 7 different forms. So during interaction, if this is changing here, this is changing here, something else is changing here, something else is changing. So total energy remains 100% only. Only what is happening is form is changing from one to other. If it doesn't happen, then will the work happen? If you buy a car, filled it with petrol and diesel and kept it, so it only has potential energy. Unless it moves, potential will not work.
search for
Huh?
science.
Yeah, it has loss now. So the energy that you actually bought, did you create it? So for day-to-day language, yes, we bought petrol. So like we gained it, then we lost it. But did we create it? No. So gain and loss is energy transaction. It's just going from one form to another. Deep, huh? So it's getting deeper. So by end of 10th, you will be like transformed into mature students. By 11th and 12th, we'll have, okay, not by 11th, that's too early. So are you understanding? The total energy remains constant. Total energy remains constant. Okay, is it making sense? That what is conservation? Conservation means constant. Energy is conserved. Okay, its value cannot change. It can only get converted from one form to other. That's all. Okay. And what conversion we are going to take place? We are going to take place conversion from potential energy to kinetic energy. So stored form of energy is potential energy. It will always be converted into kinetic. And it is both ways. Kinetic can also be converted into.
It's kinetic energy.
When we throw the object up, at the top place, it will have potential energy. When it is coming down, kinetic. Then again, it is bouncing up like a ball. So kinetic, potential, kinetic. Or let us say you have an oscillating pendulum. Look here. You have an oscillating pendulum. What is happening? So at the extreme, it has height. Here it is, let us say it is the bottom. But at the extreme end, it has height now. So it has potential energy. Here it has, at the between, while it is moving, it is having both potential decreasing, kinetic increasing. Maximum kinetic at the rest position. Then again, extreme position, only potential. Yes. So when it is rising up, kinetic decreasing, potential increasing, maximum potential. Then in between, it has both. Okay. So is that clear now? What we are trying to discuss? समझ आया? क्या समझ आया?
That energy cannot be destroyed or created. It always.
जो एनर्जी यूनिवर्स का है, वो यूनिवर्स का उतना ही होगा. It's like money. It's like money. The resources of planet Earth is whatever resources it has. Whatever we are doing, producing or whatever, we are taking raw material, we are converting into other goods. Then those goods are destroyed, decomposes, goes back to Earth. It's a cycle. Nothing is created on Earth by us, nor is it destroyed by us. We are taking everything from Earth and we are giving it back to Earth. Understood? This is called the ecosystem. कुछ हम बाहर से लेके नहीं आते. ठीक? तो ये this is called law of conservation. Right now we are applying the law only to energy. Okay? So let's verify this law. So verification of law of conservation of energy. For a freely falling object. ठीक है? So consider an object at height h from the ground. So let's take it as a rubber ball. So we have taken a object at position A, which is the top height. Right? Now at the top, what is its velocity? Huh? What is the velocity at the top?
Zero.
Zero, right? So V at A will be 0. Let us say its velocity, now it is falling down. When it is falling down, so it reaches position B after traveling vertical displacement X, let us say. So where is position B? It is x distance
X away from it.
away from A, right? So what is the height of B over here? It will be h minus x. Correct? This is the situation. Now at the top position, it did not have any velocity. But will it have any velocity
Yes.
while crossing position B?
Yes.
So let us imagine its velocity is Vb. And when it hits the ground with velocity Vc. Okay, is that clear? Everything is clear now. It hits the ground with the velocity Vc. Now let us find out what is the kinetic energy, what is the potential energy, and what is the total energy at position A. So energies at position A. At position A. So what is the potential energy? What is the potential energy at A? Let's say its mass was m, so it will be mg at h, because potential energy only requires height and the mass of the body. What is the kinetic energy at A? Half m dA square, which is equal to half m into 0, which is 0. Because at the top position VA is 0. What is the total energy? Total energy at A. Total energy at is EA equal to E at A plus AB at A. So this is mgh plus 0, which is mgh. So before fall, the total energy was mgh. Likewise, at position B, what is the total energy here? Mgh. The total energy is in the form of full energy is in the form of potential only, because kinetic energy is 0. Okay? The total energy is in the form of potential energy only. There is no kinetic energy at the top because there is no motion. Now, what is happening at position B? Potential energy at B, what it will be? mg h, h minus x. So what is the potential energy? It is mgh minus mgh. So as the potential energy reduced, so potential energy is reduced by a factor mgx. This much energy is now reduced. Okay, now let us see what is kinetic energy at B. This will be half m Vb square, right? But how to find Vb? But by Newton's third equation, Vv square must be equal to initial velocity square plus 2gx. What is the displacement from A to B? X.
But again,
And this is equal to 2gx. Why? Since VA is 0. Under what?
what that means for is equal to.
Since have you not learned this?
I have sorry.
Equation of motion.
That is what I.
Yeah. So initial velocity is here is VA. Final is VB for position P. So we'll substitute VB square over here. Therefore, what is K? Kinetic energy at B? 1 by 2 M 2gx, which is equal to mgx. So the loss in potential energy at B is got converted into gain of kinetic energy. Initially, kinetic energy was 0, but when it comes at position B, so it now has kinetic energy mgx. So at position B, the object has both kinetic as well as potential because now it has velocity as well as some height. Okay. So therefore, what is total energy? EP is equal to kinetic energy at okay. So from 1 and 2, what do we get? mgh minus mgx plus mgx. So what is the total energy? Whatever potential energy decreased got added as kinetic energy. What is the total energy now? mgx only. So total energy at A was also mgh, and total energy at B is also mgh. So is any energy created or destroyed? No. It has only changed the form from potential to now kinetic. So at B it has energy available in both forms, potential as well as kinetic, but the potential energy is reduced from mgh. What is the potential energy now? mgh minus mgh. And what is the gain in kinetic energy? Same. Whatever is lost here, are you able to catch the concept? Whatever is lost here minus mgx is lost here. Is gained here. So actually nothing is destroyed. Only form is changed from potential to kinetic. Now let us find out the potential, the energies at point C. At position C. So what is the kinetic energy at position C? First, let us find out potential energy. What it will be? What is the height here? What is the height at C? 0. Correct? It is at the ground. So it will be mg into 0. So this is 0. Why? Since h equal to 0 at C. Now what is kinetic energy at C? You've understood what is VA, VB, VC. You can write down its velocity at position A, velocity at position B, velocity at position C. Now what is VC square? You can write it as VA square plus 2G H now. Because now it has traveled the full vertical height. And VA is 0. So when you simplify it, you will again get MGH. Okay. So now I've taken initial velocity, the top one, and this is the final. I can get the same result by taking initial velocity as VB. So here it will be VB square minus VC square. VB square plus 2G H minus X, not VC square. 2G H की वजह क्या लेना पड़ेगा? 2G H minus X. Okay. And what will be VB? VB we calculated here, 2GH.
Like one can ask us to verify the law of conservation of energy stored.
All this, and you will say that total energies at all positions are same, whether it is A or B or C. But at C, the total energy is totally converted into kinetic now, because potential is 0 at C. So from potential at the top, energy is got converted into kinetic.
So we have taken that squaring because of that. We have taken that squaring plus 2GH because of that.
I've taken this as initial, this as final.
Yes, that initial.
So that's how VC square will be this formula only. Initial position I've taken as A, final position as C. Okay. So how the verification? So therefore, since so what is total energy then? Therefore, so this is the kinetic energy. Sorry. This is not total energy. Now let's find the total energy. Therefore, total energy at C. Yeah, kinetic energy at C, sorry, potential energy at C, 0 plus mgh again. This here. Okay. So have we proved conservation? At all position A, B, and C, total energy is not changing. So the law is verified. And we have also seen that it is changed from kinetic to potential to kinetic. दोनों चीजों ठीक है. So this is how we have verified. So you can actually where is A? Okay. So therefore, since E at A is equal to E at B equal to E at C equal to MGH, and therefore the potential energy at top the law of conservation of energy is verified. Okay. So can you see this? EA is equal to EB is equal to C is equal to MGH. The law of conservation of energy is verified. And the change of form is also verified. Also, during the fall, the potential energy at top is converted completely into kinetic energy at point just before hitting the ground. Okay, so change of form is also verified. So this verifies that, this verifies. And in between it has both potential and, right? And this verifies change of form. So conservation, because energy remains, total energy remains constant. And we also said energy only changes from one form to other form. So both is verified. So online students, are you able to see the board now?
Yes, sir.
Yes, sir.
Okay, with this, we will now discuss about the next topic, which is power, which is also the last topic of this chapter. So, any idea what is power?
Sir, what is the last line you've written over there?
This verifies change of form of energy from potential to kinetic. I mean, I can go on. That's enough, huh? So physics is all about study of energy. Each chapter, next is sound energy. Okay. So in different standards, we'll be covering different forms of energy. That's it. Okay. So any idea what is power?
Basically, energy or something.
What do you mean by that? And then what is potential energy?
Sorry.
What is potential energy? That is the stored energy. So how do we compare between the different
How much energy managed?
Sir, more, if we go work with more power, the work consider faster.
Yes. So to compare between different working bodies, how do we know which is more powerful? The one which is delivering more work in less time is more powerful. So you have to bring in time. How do you compare between working bodies? The amount of time they are taking to finish a task. So let us say you assign the same task to 3 different people. So one does fastest, one in between, and one comes last. So the one who does fastest, the same work done fastest has maximum power. Okay, then medium power and least power. So power is required to compare about how the energy is utilized with respect to time. So when the energy is utilized, what is done? What is done when the energy is spent or work is done? So that's how we define power. So power is defined as rate of work done. It is defined as rate of work done or rate at which energy is utilized or spent. This energy consumed per unit time. That is, E is equal to rate of work means work upon time, or E is equal to energy consumed per unit time.
What is it?
Watt.
What?
That's the unit of power is watt.
So the power drive fix the bulb in its light is called.
Every electrical device that you buy in a market will have its power rating mentioned. So what does the power rating mean? Let us say this bulb has 10 watt. Okay? If it is 10 watt, that means it is consuming 10 joules each second. Okay, so what is 1 watt? Where 1 watt is equal to 1 joule upon 1 second. Okay. This is how watt is defined.
So what is that where 1 watt equals 1 joule upon?
1 second. Second. So every electrical appliance has the power rating mentioned. So do you remember what is the power rating of your geyser? 1000 watt at least, or 1 kilowatt.
What bulb it is that?
Bulb is 10 watt. These days we have LED. These are very low energy consuming device. 10 or less than 10, right? But geyser will have 1000. Air conditioner will have maybe 1500 watts. If you are using oven, electric oven, it will have like 1000, 2000 watts. Fridge will be around 650 or less than that. 350, 650. Okay. So that is what. So let us discuss bigger units of power. Bigger units of power. So bigger units of power are kilowatt, megawatt, gigawatt. You must have heard about these units. The kilowatt is 1000 watt. 10 to the power 3 watts is kilowatt. Megawatt is 10 raised to 6 watt. Giga is 10 raised to 9 watt. So you just multiply by 1,000. So 1 million watt is megawatt, 1 billion watt is gigawatt. Okay, everywhere 1,000 is added. You also have another unit called horsepower. So 1 horsepower is 746 watt. This is the relation between horsepower and
Power and water.
yeah, earlier we used to have chariots carrying with just 1 horse or 2 horse, 4 horse, or maybe more. So Britishers actually came up with this, the relation between horsepower and so till then, since then we are using this. Why comparison? Everything is about comparison. So they might have modern machine and they must have compared how much work a horse is able to do versus the machine. Pulling up a load and all, right? So we are still using this unit in automobiles as engine horsepower. Okay. So if the engine has like 40 horsepower, so that's like equivalent to 40 horses pulling your machine. Okay. Next is then now since power is also equal to energy consumed per unit time, right? Or work done per unit time. Okay, these are equivalent things. So what about energy? Energy is equal to since E is equal to P into T, right? So using this formula, we'll define what is called as commercial unit of energy. So commercial unit of energy. So energy unit is 1 unit is given as 1 kilowatt hour. So it is power unit which is watt, time unit is second. But when power is measured in kilowatt and time in hour. So basically the energy consumed is 1 unit. Meaning if you have an electrical device of 1 kilowatt and if it is used for 1 hour, then how much energy you have consumed? 1 unit.
It's bad. Can be bad.
Why it can be bad?
It's there.
So if your electric bill actually comes in units. You can go home today, go back home. So how many units you have consumed is actually how many kilowatt hours you have consumed. So now what is kilowatt hour in joule? So and 1 kilowatt hour is equal to 1,000 watts. How many seconds are as 60 into 60, 3,600. So this is equal to watt second is joule. What is joule? Watt multiplied by second is joule. So this becomes 3.6 into 10 raised to 6 joule. So this is the relation. So now we have given you everything. So with this the chapter is completed. And in the remaining time we will do examples. Are we good? So Any doubts in power? So what did we do in this chapter? First we did work done, F S cos theta. Then we did kinetic energy. Right? Third, what did we do? Potential energy. Fourth, we did power. Fifth, we did energy is equal to power. Power has one more formula. देखो, work can be written as force into displacement. It can be written as force into displacement. And this can be written as what is S upon T? Velocity. S upon T is velocity. So power can have this formula also. So I've just given you this extra formula just in case if there is any numerical which has velocity and force given, then the power can be calculated. All right. This is it. So have we done anything more in this chapter? Have we done anything else? Work done by gravitational force. Again, for downward motion mgh, for upward motion minus m. So we can write down one more formula.
Minus because it is going up and it is going also form a straight line. By gravity.
Done by gravity. Is mgh for downward motion. And minus mgh for upward motion. Okay. And seventh you can write down work energy theorem. E theorem. What was that? Work done is equal to difference of final kinetic energy to initial kinetic energy. Oh, we did that. We will do numericals in the next class. Huh?
So by August, the syllabus will be over. No, by August, I mean by September first week.
We'll still take like 3, 4 classes or 5 classes. More than a month. Not by August. We want to.
And it's the next chapter.
This chapter, then you have a lot of numericals, then you have sound chapter, which is also quite detailed. Okay, we'll be introduced to the concept of waves. Sound.
Already know. Last year.
We'll see how much you know. And then we'll improve the knowledge.